Hi everyone. So this is lesson 1-9 from Algebra 1, and this is on recursive formulas for sequences. If you remember yesterday, we talked about explicit formulas for sequences. So we're still talking sequences, but we're talking about a different way to write formulas for them. And this method of writing formulas, I think, is a little more, speaks to your instincts a little bit more. Okay, it's what you see when you first look at a sequence. In fact, you probably said some of these things about some of the sequences we worked with yesterday. So as far as a formal definition goes, a recursive formula is a formula that relates each term in a sequence to the previous term. If you remember yesterday when we talked explicit formulas, this said a formula that relates each term in a sequence to the term number. Okay, so a recursive formula doesn't care so much about these term numbers. It doesn't care that this is term 1 and that this is term 2 and so on. Okay? A recursive formula is focused more on how do I get from 2 to 5 and how do I get from 5 to 8. And so hopefully when you look at this one, you can say, oh, you add 3 every time. Okay? And so that's kind of the difference between an explicit and a recursive. This is recursive down here that I'm writing in pink, where you look at a sequence and you say, oh, I'm going to start at 2 and add 3 every time. The explicit formula, which I'll kind of note here in green, takes the term number and tries to come up with the term. Okay, so let's talk advantages and disadvantages. This is really easy to do, right? This is really easy to say, oh, look, it goes up by 3 every time. Okay, no fancy math there or anything. However, if I wanted to jump down to term 6, I don't have a way to just get there. I don't have a way to just find term 6. I can't find term 6 without counting all the way up, right? I would have to kind of follow this train all the way down. And that means that if I were to ask you for, term 27, we might be here a while, okay? Now, the explicit formulas are harder to come up with, all right? I'm going to show you the explicit formula for this one. I do not expect right now that you know how to write this, that you know where this comes from. Okay, the explicit formula for this sequence is 3n minus 1. Okay, what that means is to get any term in this sequence, I take the term number, multiply it by 3, and then subtract 1. And if you check, that works, right? If I do 3 times 3 and then subtract 1, 3 times 4, subtract 1, 3 times 6, subtract 1. Okay, so mathematically, this is more difficult to come up with, but it's better in the long run if I wanted to jump all the way down to term 25, okay? We're not going to get into this so much today. In fact, today we're really focusing on this recursive idea because both of these are important, but I really want you to just be able to use both of these types of formulas, the explicit and the recursive, okay? All right, so let's get some notation out of the way, just some different things that are going to pop up in these problems. And some of this is common between the recursive and the explicit formulas. So first off is the n. Anytime you see an n, that represents a term number. Okay? Which means when you see this, t sub n, that's referring to some term in the sequence. Okay, specifically, it's the term in position n. Okay, so if I say T3, I'm asking you for what term is in the third position. Okay, the new one that kind of goes along with this recursive formula piece looks like this. T sub n minus 1. Okay, and what that's talking about is the previous term. Don't get bogged down by the minus 1 thing there. I think that that makes it look more mathy than it really is. This is just nerdy math talk, okay? And so if I'm looking for term 3, then the previous term would be term 3 minus 1, otherwise known as term 2, right? And so that's all this is, this notation right here, which is going to be really important today. All that's saying is look at the last number in the sequence and then keep carrying it forward, okay? So the notation for these recursive formulas can bog you down a little bit, and you're going to see it in just a minute, but there's 2 pieces to it. you have to give the first term, and then you have to give a rule for generating the rest of the sequence. So if you think back to this sequence we did up here, if I were to describe this to you, I would say something like, well, we're going to start at 2, and then we're going to keep adding 3 over and over again. Okay? Those are the 2 elements you need to describe a recursive formula. Okay? In notation, in the correct recursive notation here, this is what this would look like. I would say term 1 is equal to 3. Nope, just kidding. Term 1 was equal to 2, wasn't it? That's this. Okay? Term 1 is equal to 2. And then to get any other term in the sequence, which is what that's saying, I'm going to take the previous term and add 3. Okay? So term 1 is 2. This is telling me where to start. And so when I want the next term, I'm going to take the term that came before it and add 3 over and over again. So this right here, this plus 3, that translated in right here. This is what recursive notation looks like. So if I ask you for a recursive formula or a recursive definition, both of those things look like this. Okay, let's see if we can start working with one of these. So when I look down here at example 1, it says T1 equals 26. And then to get the next term, we take the previous term and subtract 5. I want to say that in even better English. Okay, I would rather say that without using mathy talk at all. So what I would probably say here is something like this. Start at 26, subtract 5 over and over and over again. That's how this sequence is generated. All right? This is what I'm looking for as far as a verbal description. Now, when I go to list the first 5 terms in the sequence, don't forget that you already have 1, right? So my very first term that I list should be 26. And then I'm going to subtract 5. So I'm going to go 21. Then I'm going to subtract 5 again, and I'm going to get 16. Okay? Then I'm going to subtract 5 again, and I'm going to get 11. And then I think one more, and I get 6. Okay? So notice how I didn't try to actually plug numbers into this formula. I just interpreted it. I just looked at this and said, okay, this is telling me to subtract 5 every time. Don't get bogged down in trying to plug numbers in here. Okay? If you wanted to see what it looked like when I'm plugging numbers in, here's what's really happening. I have T1, which is 26. And then when I want to find T2, it tells me that I need to take term 2 minus 1 and subtract 5. Well, term 2 minus 1, that's just a strange way of saying term 1, right? And term 1 is right here, 26. So then I'm going to do 26 minus 5, and I get 21. Okay? If I wanted term 3, I would do term 3 minus 1 and subtract 5. Well, term 3 minus 1 is just a funny way of saying term 2, right? And term 2 is right here. So then I'm going to go 21 minus 5, and that makes 16. And it just continues on. So this is what the notation is actually doing. But I would love it if you could just get to the point where you can do this, where you can just list out the numbers without having to go through all of this mess. Okay? Okay, moving on. A couple more examples. So it says, write a recursive definition for each sequence below. That recursive definition and recursive formula are really the same thing. And you're going to see those words kind of used interchangeably. Don't get confused when you see one or the other. Okay, so recursive definition is the same as a formula. And so we want to just say what's happening in each one of these things. Well, when I look at this one, it looks like I'm adding 4 and adding 4 and adding 4. And I just want to make sure that keeps going. Yep. So here's what my formula is going to look like. Remember, two parts. So we always start by saying term 1 is something. Term 1 is 2. And then to get the next term, I'm going to take the previous term and add 4. Okay? And that's it. That's where I'm going to leave my answer. This says start at 2, add 4. Well, let's look at this one. What's happening to get from 18 to 6? Now be careful here, because you might look at this and say, okay, I'm subtracting 12. But then I clearly didn't subtract 12 to get from here to here. Okay? So it's not subtraction. Let's think about how else we could make something smaller. This is actually division by 3. Right? To get from here to here and here to here, I'm dividing by 3. So in sequence notation, I would list that first term as being 18. Okay, always start with that. And then I'm going to say to get to the next term, I take that previous term and divide by 3. Okay, probably cleaner ways I could have written that, but this is all I'm doing is I'm saying take the previous term, divide by 3 over and over again. Okay, so let's take a look at that next one. That next one's a little bit tricky. I go from 5 to 11, 11 to 22, 22 to 45, 45 to 91. I think we're going to skip that one. I think there's a mistake here because here's the pattern I'm seeing, and this is tough to see right now. Okay, this was put on here as sort of a challenge problem, but I think there's a mistake here. That to get from 5 to 11, I could add 6, but I know that's not going to work, right? Because that doesn't keep going down here. I think it's meant to be you double it and add 1. So 2 times 5 plus 1 is 11. But then look at what happened here. 2 times 11 plus 1 does not make 22. But that works for the rest of them. 2 times 22 plus 1 is 45. 2 times 45 plus 1 is 91. So I don't know if this was thrown on here to, be a trick question for you, or if there's a mistake right here. But either way, we can't do this one. Okay, there is no recursive formula for that one. So sorry about that. Didn't see that one coming. Let's hit example 3. Word problems here. Josephina has visited 11 states, and she's going to visit 2 more each year. So we've talked about ways to write equations for something like this, but now I'm not just writing an equation, I'm writing a recursive formula. And I want the total number of states she has visited after n years. Okay? Word problems can be very tricky. And I'm about to show you something that's tricky about this problem, and it doesn't necessarily show up everywhere, but you will see it again. Okay? Notice that it says n represents years, and specifically it's after n years. So when I go to define my term 1, all right, and I'm going to use an S for states, my S1 really needs to represent after 1 year. Okay, that's because n represents the number of years after n years. So S1 represents how many states I've visited after 1 year. I visited 11 states right now, but after that first year, I will have already visited 2 more. So my S1 here is actually 13. Okay? And that's confusing. I can see why you might be confused by that, but this right here, this 11 states, this is what's known as the initial value in this type of problem, okay? And that means it's actually term 0. So this is how many states I have when no years have passed, okay? And so this would be, like if I had to identify S sub 0, it would be 11, all right? But I don't usually identify S sub 0. I need S sub 1. Okay, so sometimes you have to play around with that first value to decide which one is actually going to be your term 1. And I always just go back to, all right, this 1, if I put it in this wording, is this number reflecting what I want it to? Okay, the second part of this should be easy. to get the total amount of states she's visited in any other year, I'm going to take the previous year and add 2, because that's what we said is happening. We're adding 2 every year. Okay, so be careful about that S1 on that one. And then write the first 5 terms of this sequence. Well, S1 would be 13. That would be after 1 year. After 2 years, I would have seen 15. After 3 years, I would have been to 17. 4 years, I would have been to 19. And 5 years, I would have been to 21. Okay? And so all I'm doing is just increasing by 2 every time. But notice that 11 didn't actually make it on my list because it's not one of my terms, because it's not after a certain number of years. Okay, sorry for that fumble over this one up here, but otherwise you should be good to go on tonight's homework. Tonight's homework actually goes back and reviews explicit formulas and recursive formulas. So if you want to focus just on what you learned just now, I would start with Lesson Master 1.9, and then you can backtrack to 1.7 if you want to. Okay? And I will see you in class very soon.